Okay.
We are recording this, so I guess they can catch up when they're...
Sure. Well, if you think it's looking pretty good, I would say we'll get started.
Okay, let's give it one more minute, if that's okay.
How are we looking now, Christy?
I think we're good to go.
Okay. All right, we'll go ahead and get started then. Good morning, everyone, and thank you so much for joining our educational session today. Our topic is South Dakota's Next-Gen 911 GIS Data and Managed Services. I'm Shawnee Reckenbaugh, the State 911 Coordinator with the Department of Public Safety in Pierre, and I am also the staff for the State 911 Coordination Board. Myself and Ted Rufflett, who is the chair of the State 911 Coordination Board, are going to take just a few minutes here at the beginning to go through the first couple of slides, and then we'll turn things over to the team from GEOCOM who will present the remainder of the session today. So first, a couple housekeeping items. The session is being recorded, so if you have to drop off, or if there's someone in your area that couldn't attend today and listen in, we'll have a recording of it, so that'll be available after the presentation. And in addition, all the lines on the phone should all be muted. I think we have them kind of muted from our side, but feel free to mute your line on your end as well. And we'll do that, of course, to keep the background noise to a minimum. And with all the lines being muted, we're going to handle the questions through a dialog box on your screen. If you look over to the right-hand side of your screen, you should see a control panel. And mine has a little red arrow at the top that I can make it larger or smaller. And in that control panel, you'll see a question box. And so at any time through the presentation, if you have a question, feel free to type your questions in there. It'll go specifically over to just Christy, so the rest of us won't see it, but Christy will have those, and then she can kind of keep an eye on those and group like questions together, or if there's a particular time during the presentation where your question would really fit in, they'll do that and or answer them towards the end of the session, and we'll have some specific time set aside at the end for those questions. So with that, I think we're ready to move on to the next slide here, our agenda for today.
Can you see the next slide?
I do not. I'm still on the main beginning slide.
Okay.
Yep, now I see it. Okay, so this is our agenda for the call today. We'll do introductions here in just a moment, and then talk about Next-Gen 911 in South Dakota today, an overview of Next-Gen 911 and GIS, and then we'll have GIS Data Analysis and Collection, how that's going to work, and then lastly, we'll have some additional time for questions. So I think first, I've introduced myself, you know who I am, but I'd like to introduce the rest of our team for today's presentation. Ted, would you introduce yourself?
You bet. Thanks, Shawnee. Ted Rufflett. I'm the chair of the State 911 Board and also work for Pennington County 911, and looking forward to visiting with you all today.
Thanks, Ted. And next I'll go over to Christy at GEOCOM for herself and the rest of the GEOCOM team.
Great. Hi, I'm Christy Hayes. I am the project manager with GEOCOM working with the South Dakota team. Sean or John?
And I'm Sean Lehman. I'm a GIS project manager with GEOCOM, again working with Christy, John, and the State 911 Board and everyone for the state. So looking forward to this project.
Yeah, and I'm John Kraft. I'm a GIS Data Manager here at GeoCom, and I'll be going over the analysis and data collection with you guys here in a little bit.
Great, thank you guys. We'll go next to the next slide, please, Christy. So just a couple minutes to tell you about kind of the situation today and what we're doing, why we're doing it, and where we're headed. So presently in South Dakota, we have the legacy 911 system, and it has served us well for many decades. However, the last 2 decades have brought extensive changes and advances, of course, to the way we communicate. The legacy system was built with telephone technologies from the 1970s and was originally built to handle landline phone calls and not cell phones, VoIP phones, and other communication devices that share data. So cell phones and other wireless communication devices have made it necessary to implement next-gen 911 technology. And our next-gen 911 system will really take us into the 21st century and allow all of our 911 centers to catch up with the current communication technology that's out there, and then allow us to keep pace as that technology continues to evolve on what feels like a moment-to-moment basis. Right before Christmas, we signed a contract with Telecommunication Systems, or TCS, to build the new statewide next-gen 911 system. And the new system will be comprised of a centralized 911 phone system that all of the 911 centers in the state will migrate to. All of those 911 centers and the new 911 phone system will then be linked by a secure and redundant broadband connection. And SCN Communications, based in Sioux Falls, is the subcontractor to TCS that will be the broadband provider for the next-gen 911 system. This whole infrastructure upgrade will position all the 911 centers in South Dakota for many operational and technology advancements. Some will come right away, and others in the near future, and then many more down the road, of course. With that, I'm going to toss it over to Ted for some more information.
Thanks, Shawnee. And yeah, I just want to add a couple more things here about the project before we turn it back over to GeoCom. So in addition to the contract that the 911 board has signed with TCS, then of course we've also contracted with GeoCom, who's out of St. Cloud, Minnesota. I think many of you on the phone may be familiar with them. They've been doing work in South Dakota for many years, and we're very happy to have them on board for this project. Their first task is going to be to gather 911-related GIS data from the various local sources around the state that are maintaining that data, and that's the data that's being used by the 911 centers today in their mapping systems, whether it's in CAD or a standalone system. What GeoCom is going to do is aggregate all of that data into a series of statewide layers that are going to be used in the 911 system. They're kind of used in the background. That's what helps route calls and performs other functions within the next-gen system. Now, currently, your 911 coordinators around the state, their primary focus is to add new streets, keep the MSAGs updated, and work with phone companies and Intrado and CenturyLink to fix customer phone number problems in the 911 system. Now, when the next-gen 911 project is completed, the 911 coordinators and their local GIS support folks, instead of doing that kind of work with Intrado for the MSAG maintenance, they'll actually be uploading that current GIS data to GeoCom. GeoCom will process it and then push it over to TCS, where it'll be used in the 911 system. And other things that the 911 coordinators are doing today with Intrado will be done with TCS. TCS will take that part of the project over as well. It'll be very similar when you're fixing customer numbers and stuff, but it will be with a different company. These changes are all part of the next-gen 911 project. GeoCom is going to play a critical role in ensuring that the GIS data is always ready to support the live TCS next-gen 911 system. And you know, I think most of you would agree that CenturyLink and Intrado have done a good job providing the legacy 911 system to us all for many years. But as we move on to the next-gen system, TCS and GeoCom will be the new providers of that service. and we look forward to moving forward with them over the next 5 and 10 years. We have a 5-year contract with TCS, 10-year with GeoCom. So we're very excited to get this project started, get these tasks going, and I want to thank you all for taking time out of your day to join us. And if you have any questions, like Shawnee said, type them in, or you can get with Shawnee later by email or phone, and we'd be happy to answer any other questions you might think of later. So I think I'm going to turn it back over to Christy now.
Great. Thank you, Ted. Well, as Ted mentioned earlier, this part of the project, we are going to be responsible for developing and setting up the seamless gapless GIS data set that's going to be provisioned into the standards-based ECRF and LVS system. And part of that implementation part of the project is there are several things that are going to be happening. We're working with the state right now on finalizing a statewide GIS data model. We're also developing GIS maintenance workflows. We're going to be doing county GIS data assessments, and we're going to be talking about that in more detail here in just a minute. But there will be some assessment reports that will be provided to the counties along with a remediation period, as well as a second round of assessments. We're also going to be providing some training on the system for the county's users, and we'll be presenting the GIS maintenance workflows at that time. And then we're going to implement. We're going to do all of this work this year and be completed by early December. So right now what we'd like to do is kind of give everybody an overview of how GIS, the importance of GIS, is going to play into the next-gen systems going forward. I'm going to turn it over to Sean.
Good morning, everyone. So yeah, I guess a couple points have already kind of been pushed and talked about already about where we're going and where we are today. So within this enhanced 911 system currently that the state is running on right now and the local entities are running on right now, this GIS data, it's being used to plot those 911 calls and those incidents within that PSAP. That GIS data, it's being used if you have the automatic vehicle location functionality within your CAD system. Unit recommendation, what's the closest unit to that incident. So really the GIS data in this E911 environment, you really need to have that data almost near perfect. Is kind of the preferred method because you're now trying to locate that information within the CAD system. The frequency of this data, once the data gets pushed into a CAD system, then it really needs to be maintained, and sometimes the data doesn't always get pushed. Maintenance updates don't get pushed into that CAD system as frequent as it should. Maybe they are doing it every quarter. There's been times where it's been 1, 2, 3 years that I've heard of where the mapping data used to locate that incident, it's just out of date. So again, if there's any kind of development that's taking place within your county, there could be periods where that new information, that new location information just isn't in this CAD system. So where we are moving forward in this next gen is all that location information, it's going to be validated up front, kind of at the beginning of this, so that when that call comes in, that information is readily available. So that's why the GIS data needs to be perfect. And John's going to be talking about this, but we're going to be doing some information to pass along QA, QC results back to the counties to kind of identify discrepancies in that data. And then again, where we're moving towards the state in this next gen project is maintaining that. We're going to give you the capabilities of maintaining this so that new subdivision information can get pushed into the statewide system and provisioned on a regular basis. So we're going to kind of walk through that on this next slide, this bigger picture of where this EZNet, this cloud-based next-gen system's going. So the EZNet, this cloud-based, this emergency service IP network, it's a more robust system, and it really starts off, and how it comes together is we have all this subscriber information, we have the communication service provider information, all this addressing information is going to be located in this list server. So it's going to be centralized, located in this this server, so that next we can take this information, and these green boxes, which you'll see, this is where the GIS data is going to become really important, because we're going to validate all that subscriber information to the GIS information, and we're going to validate that. And it's going into this location validation function where it's going to say, yes, it's valid, or no, it's not. And then this information now is going to be stored in this list environment. And this is all before a call is going to take place. This is a pre-call for service. All this information is going to be stored up front. So then when we actually get a call, this call is going to be placed. That location information, because we validated against the GIS, is going to be passed along to this border control function, which then gets passed and routed to the ESRP. I know there's a lot of acronyms going on here, but this location information is getting passed along, it's getting routed, and it's now going into this validation environment again to find out where does that call plot. And so we're plotting to a location. That underlining boundary information is going to say, hey, it belongs, this call, this location is, in this example, belongs to PSAP A. So then that information then gets passed along to PSAP, where you see this mapping information that's located, and that's kind of what you see in this mapping environment. You'll see that the caller location is mapped, and it's probably pretty traditional what you see today. So then how is this data going to be maintained? How are updates going to place? Again, we have these green boxes at the state level. This data is going to be maintained at the state. As Ted mentioned, we're going to have this seamless statewide address point file, street center line, emergency service boundary, admin boundaries, etc. That's going to be maintained at the state, where updates can be applied, quality control, quality assurance reports can be validated, coalesced, and then this data now is all provisioned, all these green boxes, so that you have this master statewide data. So again, that's why the importance and what we're going to be working with everyone over the next year to get this statewide data up and running in the best quality as possible. And again, this is kind of just another big picture type, how the call routing is going to take place in the cloud. This information is going to get passed along. It's that address location, since we validated it very early on, is going to plot within a certain boundary zone. That information, such as your call, any text, you'll be able to do video, etc. This information is all getting passed along to the PSAP. So again, this is kind of a bigger picture. The end goal is what we're trying to shoot for, and again, we're looking forward to working with everyone within the state.
Thanks, John. This is John Kraft once again, and I'm going to talk a little bit about the data gap analysis with you all, and what that really is and what it entails. And before I get started, I'm just going to kind of talk a little bit about this analysis. A lot of times when we've done these with various clients in the past, sometimes people get worried that, you know, we're going to give them a report card grade, like an A, B, a C, or a failing grade, an F. And so that's really not what these gap analyses are for. They're not to say, hey, your data is no good or your data is excellent. It's really just to kind of take that data and give it a good overview and let you know of the shortcomings that need to be repaired or fixed before we load that data into the statewide GIS data set. And so the gap analysis is a way for us to analyze your data and provide back to you a report, so you can use that report as kind of a roadmap on how to get your data to the standards that need to be met. And so some of the things that we need to do this gap analysis are your various GIS layers, and I'll talk a little bit about those in a moment, but, you know, center lines, address points, and such. We also use a copy of the MSAG and the ALI database for collection to make sure that all of those MSAG records are represented on your street, if they're valid MSAG records. All of the ALI records are represented in the point or could be found on the street. And so we really look at it in depth to ensure that all of that stuff is being met. We're going to perform gap analysis on each county. And so what we're going to do is we're going to be requesting data from all the counties. That would include the data layers I'm going to go into in a little bit. And then we would take that data, we would run it through our custom tools here at GeoCom, and we would then put together a report and send it back to each county for their review. We're also going to do a statewide GIS data set analysis, and this here is a little bit more regards to like overlapping areas around surrounding counties. So we want to make sure that everything is topologically clean between County A and County B. So we're going to run that statewide data set to make sure there's no disjoint segments from one county to the other or overlapping centerline ranges between counties. So that'll be a kind of a statewide level. We do that one on a little bit later down the road. As far as the report goes, the report, like I said, is going to be one report per county. We're going to send those out, which will give you time to review it and kind of use that report as a roadmap on how to get from your current state of your data to where we would like it to be to get into that next Gen 911 system for the statewide database. The report's going to contain all sorts of information on topology, on ranging, going to look at standardizations. One of the things for this project that we're kind of going towards is NENA standards. And so for NENA standards, they're using the USPS street type suffixes. So for example, AV should really be AVE, or avenue should be listed as AVE. So we want to make sure that's consistent statewide. So we're going to be looking at that and reporting those findings back as well. So let's look a little bit more in depth here at some of the actual analyses that we're going to do on the next slide. And we'll start off with the address point data consistency and completeness. So these are just some of the QA/QC checks we're going to do. There's quite a few of them, but we'll start with the address points. And what we're looking at here, like I said, is the consistency and completeness. Does every single feature in your address point file contain a valid address number? Does it contain a valid street name? Is it standardized to those USPS street type suffixes that I mentioned a moment ago? We're going to look at all of that to ensure it's completely populated, as well as the zone information. We'd want to make sure that since this is a statewide data set, that those zones are completely populated. We don't want to have 101 Main Street existing in 5 different cities across the state without proper zone information. So that city value or jurisdictional values are going to be very important as well to make sure they're populated. We'll be looking at that stuff. Another thing we do with the address points is we kind of do a comparison. We're going to compare the points against that tabular alley data set. We're going to compare it to the road center lines. And what we're looking for is we're looking for any discrepancies in that data. Is the alley record represented in the points, yes or no? Does that address point match a segment within your centerline file? We look at it in a number of ways. We look at it in terms of even and odd addressing to ensure that it's on the correct segment of roadway. We look at it to make sure that it's between the low and the high ranges of that street center line as well. We look at the naming to ensure that the naming of that address point matches the naming of the center line, that the zones match as well. And the whole purpose of this is for when that gets into the system, we have these locators that are built, and we want to ensure that every call coming in can be plotted to that address point or as a secondary locator, that road center line. And this comparison is pretty important to make sure that everything is matching and going to come up appropriately. We also look at the road center line data consistency, very similar to how we do the address point data consistency. Once again, we're looking at those same standards. We want to make sure that everything is standardized the same across all data sets across the entire state. So we're going to look at that standardization of the roads. We're also going to look at the consistency of those roads to make sure every road is in the data set. And we do that by a comparison against that MSAG. So we'll report back any findings where something's not represented. It could be an individual road where the name is just not found anywhere in the road center line and it exists in the MSAG. It could be an individual, block of ranges that is just not represented in the data. So we're going to report that back as well.
John, would you mind explaining what ALI and MSEG is to the folks that might not be familiar with those two terms?
Yeah. So there's different types of data. There's the GIS data, which is what's represented on this screen right here. We have address points, road center lines. Excuse me. I'm going to get a drink of water. Hang on. So we have that GIS data. There's also tabular data. So the MSEG stands for Master Street Address Guide, and what this is, it's a tabular data set that represents every street center line, and it gives a low and a high range. So if you picture your map data, your GIS data, you might have Main Street going through a city block, and it might be segmented into 10 different street center lines. So in your GIS data, you would have 10 records for Main Street. The MSEG might just have one record for Main Street, but it's going to incorporate all 10 of those street centerline segments with that low and that high range. So it's more of a tabular data set that lists out all of the streets within that jurisdiction. The ALI database is essentially all of the subscribed phone numbers. So you have a phone number that goes through in this tabular data set, and it's registered to a physical address. And so those physical addresses really should be represented on the street center lines and in those address points. And so the MSEG and ALI are tabular data sets that are currently being used in the existing methodology on how to get those calls placed. And what we're moving towards is all of this GIS data. So we're going to make sure that all of that data is represented in these points and these lines. And there are people that might not have an address point data set. Perhaps you have a parcel data set with addressing information. It's possible to create an address centroid or something like that as a starting point. And I know the assessor's office is more interested in sending out tax bills than they are the physical location of a parcel. So sometimes, the situs information in those parcel boundaries might not be as accurate as needed, but it's a good starting point if you don't have a point layer. Does that answer your question, Christy?
Yes, thank you.
So that kind of finishes up the address point and consistency, the road data consistency and completeness, where we're talking about standards and making sure that everything is standardized the same way. Another thing that we're going to look at is those road centerline address ranges, and this is kind of a critical one. If you imagine a road in your GIS data, we'll go back to Main Street. Let's say there's 10 segments of Main Street, and 5 of those segments have overlapping ranges where the low and the high range, depending on the side of the street, overlap one another. If a call comes in for one of those ranges that overlap, your dispatchers are going to be presented with multiple locations to dispatch to, and we want to make sure that that doesn't happen. So we're going to look for all of the overlaps in the data, and this is kind of one of those critical things where I would definitely, if I were in your shoes, I would spend time looking at those overlapping ranges and make sure we get them as clean and correct as possible. As Sean mentioned earlier, all of the routing functionality now at this point, when we move forward and switch this on, is going to be based off of the GIS data, and that GIS data needs to be as accurate and precise as possible. So overlapping ranges shouldn't exist. That's internal and external. So from county to county, if you have overlapping streets from existing in one county and the other county, we'd want to make sure that those kind of get dealt with as well before it gets pushed into that live setting. Another thing we look at are topology checks. This is dealing with not only center lines but also boundaries. So the next bullet there is boundary layer consistency and completeness. And I'm going to kind of talk about these two interchangeably at the same time. Street centerline topology is important if you want to route ever in the future from point A to point B. Maybe some of you are currently using routing. If you have a street centerline that is not perfectly connected at an intersection, you might not be able to route directly through. The routing engine in your software might take you, on a detour around a longer way around. So we'll look at the topology to ensure that topology is clean, and we'll report back any errors we see there. in regards to boundaries, we'd want to make sure that all of the boundaries are seamless. There's no gaps, no slivers, no overlaps between existing boundaries. Going back to your center lines, where a street center line crosses a boundary, we'd want to make sure that all of those street center lines are split at boundaries. If you imagine populating a street center line with a left or a right boundary, and that street exists in two different boundaries, it's difficult to pick one of those two. So it's good to split your streets at all boundaries as well. And we're going to look at all of that to make sure that everything is consistent. As I said, there's a number of QA/QC checks that we're going to do that you'll see in these analyses. And the main goal is, like I said, it's not to point fingers and say somebody's data is bad or somebody's data is perfect. It's really just to give you an idea of any inconsistencies in the data or issues that might be in the data that should be corrected and fixed before it gets kind of pushed up into that statewide data set. And we're going to do 2 of these analyses at least. We're going to do an initial one that you can use as your roadmap during your remediation methodologies and processes. And then we'll do another one at the end just to kind of show you the improvement that you've made on your data. So that'll be nice. Let's move to the next here.
We've got one question, John. Is it important for the address ranges on the streets to match the statewide addressing grid?
Well, I'm going to probably turn that over to Ted, but I'll throw my 2 cents in there first. My 2 cents is that, there's going to be anomalies in the data. So, one of the errors we're going to report back, for example, on a street center line with dual ranges, you typically have odd addressing on one side of the street and even addressing on the other side. For the addressing authorities in a typical setting, that's the way it would be done. We do know that there's going to be issues in the data where, for example, there's a mobile home park that has consecutive addressing, 1, 2, 3, 4, all on the same side of the street. So in that case, you have a known error in your data. There's not much you can do to correct that unless you go out and readdress all of those homes, which I know as well as most of you do, that's almost impossible to do sometimes. So it's okay to flag certain anomalies in your data as known issues. And once you've flagged those known issues, say for example that first analysis we give you, there's a bunch of known issues in there, you would flag in your data, and we'll kind of go over this during a request of the data, but once you've gone through all of the report, you can flag those known issues, and then on that second report, they wouldn't be reported back to you again because you flagged them as, hey, we know this is an issue, there's nothing we can do about it, it's okay. My assumption is that something similar to like that would be towards the question there. Ted, you have 2 cents on that?
Yeah, I just want to have Christy give me the question again to make sure I didn't hear the whole question initially. So what was it, Christy?
Is it important for the address ranges on the streets to match the statewide addressing grid?
Right. So in other words, are the addresses that were issued out in the field, do they actually match the statewide address grid? That's important completely outside of this project. I mean, if you understand how the statewide addressing system works, if you've got a ranch out in ranch country that was issued an address that was 1 mile off the state grid, then when responders go there, they understand that system, and they're looking for an address that's actually 1 mile north of them. So yes, that is important, and that would be a big problem irrespective of this project. Anytime an addressing authority knows of those things, they need to be fixing those kind of problems. And then, so yes, if that's in, and then if it's inside of your data now that you're going to upload to GeoCom, they're like I don't know, I think it was Sean said, that's going to pop out right away, and they're going to flag it to you. So, the right action would be to fix it and correct it in the data. That's always the best thing to do, because when you're talking about 911, in the old legacy system, you're shooting for 95% accuracy between your physical addresses in the field and your MSEG, that they match. In GIS, the standard's higher. It's more like a 98%. So, this is going to be a good opportunity for all of us with GIS data to have somebody do a analysis and comparison of us, because we all may be sitting there thinking, hey, we got great data, and we might find out, oh, geez, here's a bunch of little issues that we didn't know of. And unfortunately, a lot of times you don't find out about those problems until you have an actual 911 call, and you end up with a delayed response, and that's what we don't want to happen. So if you've got problems out there like that, address that doesn't match the grid, it's an even address on the wrong side of the road, on the odd side, all those things, you should always be trying to fix those and improve your data for public safety reasons.
Okay. The next question we have is, what is your plan for counties that do not have a GIS or CAD road centerline data capabilities?
Yeah, so that question was kind of asked yesterday as well. That one was kind of directed towards the reservations, like if they were going to be involved in this project or not. But we do have access to some street centerline data that we could coalesce in there where that stuff is not available. Once again, I'll probably turn this over to Ted in terms of any particular counties not having GIS resources.
Right. And so part of the project and part of the work GeoCom will do is to help us identify any of those areas. So obviously we don't want to have a statewide data layers that have whole counties or parts of the county missing. So, once we get their analysis back and find out what we're missing, then while they go to work analyzing what they did get, part of what their team and our team will do would be to analyze what the other, the DOT, for example, South Dakota DOT has a complete set of center lines for the whole state. There's other ones that are commercially available. The one-call utility locators folks have a statewide set. So there's other resources we can go to get data for areas and counties. And the problem with a lot of that data is you got the road center line and some basic data, but a lot of times you don't have the address ranges. You don't have left and right city and that kind of stuff. So we may have to do some work to get that. We don't want holes. We're hoping we'll get as much as we can, and we're just going to deal with those things as they come up.
Yeah, these are good questions. Are there any more there, Christy?
I don't see anything. I have a statement, but I'm not sure if it's a question, and it's regarding the addressing grid. The statewide addressing grid comment, it would not match the state grid in towns with their own grid.
Well, right. So the state addressing grid wasn't intended necessarily for municipalities. I mean, there's some places where it was used, but the rural addressing grid was designed to be used in the parts of the state starting in 1992 that had never been addressed before.
Okay.
So it's a 5-digit address grid where all of those digits in the house number have meaning. The first 3 tie to a grid number. The 4th number refers to tenths of a mile from a section line, and the 5th digit is odd or even side of the road. So in this data, you're going to have one road that is in a city that's 2-digit address range or 3-digit or 4-digit, and then it gets out into the county and now it's 5-digit. That's the reality of the data, and those roads flip back and forth as far as what grid any area was addressed off of. But GeoCom's used to dealing with that and understands that, and it works within 911, and your MSEG reflects that today, so it won't be a problem.
Okay. Got one other statement too. South Dakota DOT only maintains a public road inventory. Gated communities, for example, are considered private roads and would not be included in our inventory.
Right. So there's all kinds. We could spend the rest of today talking about exceptions, problems. Mm-hmm. The point is that we're going to work very hard to have a complete data set. Nothing like this has ever been undertaken. We have a complete MSEG today, and so we're going to try and match that with a complete GIS data set. And nobody said it's going to be easy, but we got to get started somewhere, so that's what we're doing.
Yeah, and just to kind of throw that out there too, like this initial phase of this project is going to take probably about a year or a little bit less than a year right now, but yeah, it's not going to be something that happens overnight by any means. So we'll move on to this next slide here, the GIS analysis. We talked about some of the QA/QC checks just a moment ago. this image just kind of goes over a little bit about where various source data might come from. So here on the left-hand side of that image, we've got 3 different color boxes. We have some data coming from local 911 authorities, or maybe a county authority, or maybe even a city has their own GIS data. So we can get data sources from various places, or even something else I'm not thinking of. There's the addressing authorities as well for change requests. So if there's a new subdivision built, or for some reason a house changes an address number or something like that, that could be a source of some data as well. Old map layers or anything like that, DVDs, CDs, that's a source of data as well. So what we're going to be doing is we're going to take all of this source data from these authorities. We're going to kind of convert it into a common statewide projection, coalesce it all into a statewide database. And at that point, once it's in that statewide database, it's going to be kind of staged in the ECRF, the LVF, and the PSAP servers. So that way, all 3 of those various servers are going to be running off of the same data. Sean kind of went over that EZNet cloud a little bit ago about how those all play into effect. But this is kind of just an overview of how that data is going to kind of go from, let's say, that county authority down to that state level in those servers. On the next slide.
Actually, we've got a question. Will there be any funding available for counties who may need major changes or upgrades, yet lack funding or manpower?
I think that, once again, would probably be a board question.
Yeah, again, is there funding available? No, there's not funding available. There's not funding earmarked at the 911 board level for that. So, again, we'll see where the analysis takes us, see where we have gaps, and work from there. Every PSAP is currently required to have mapping for their 911 service area. So there should be GIS data, some kind of mapping data at every PSAP for the entire state of South Dakota. Now, we have invited the tribes to participate. We want the tribes to participate. We would like to have the entire state, including the reservations. So what I'm speaking is I don't know what's available there, but for the local PSAPs, the 29 local PSAPs who fall under the administrative rules, they are to have that data already. So that data should be there. It's just a matter of trying to find it and deal with the missing pieces or areas where we don't have it as we go forward. And hopefully we won't find a lot of those.
Okay.
Yeah, that's often one of the things we run into is people not knowing where the data is or how to find it. So that's a good point. Yeah.
Okay. We had another question about what funding model what is the funding model to support all of this? And I believe Ted answered that question. I didn't know if you had anything else to add, Ted.
Well, I mean, the local PSAPs, of course, they get I think 85 cents of the 911 surcharge, and that's intended to run the PSAP operation. Well, the problem is in South Dakota that funds about, I don't remember what the exact number was. Shawnee might know, 45%, I think, 50% of the statewide operating costs. So, some PSAPs use their surcharge funds to help pay for GIS data to keep their maps updated. But GIS data obviously is used extensively by all departments of local city and county government. It's not just a 911 thing. So 911 PSAPs are users of GIS data. So, you typically don't use exclusively 911 funds to pay for your GIS data. It can help pay for that data. So, a county that doesn't have it or doesn't have it's really a county and city issue. It's not a PSAP issue. It's not a 911 issue. GIS data is very basic. It's been around a long time. It's something that everybody should have by now, or the district, the first and third planning districts here in South Dakota maintain lots of that kind of data for lots of counties. There's a lot of ways out there that a given county or a city that may not have that data can get it and begin to keep it maintained and updated and use it if they don't have it today.
Okay. All right.
Great. So let's talk a little bit more about the data. Some of the data that we would want to get from you all are the road center lines. Ideally, as I mentioned, these road center lines are going to have naming. They're going to have left and right range values. They're going to have zone information. We're also interested in getting the service area polygons, whether fire, law, EMS, PSAT boundaries, authoritative boundaries, the site structure points or address points. Once again, valid address numbers, road names. Road name alias table, if that's not embedded in the road center line feature class, and you have an external table, we'd like to get that as well, so we can have a statewide road name alias table. County boundaries, municipalities. So these are some various GIS data collections that we'd be interested in getting and that we're going to be requesting from each of you, each of the counties. And then one thing to kind of touch on with this, and we're going to be sending out a document kind of talking about this as well, but our unique IDs. When we request this data, it's important to ensure that each of the feature classes have unique IDs associated with them. And I know every feature class has an object ID or some sort of primary key. And the problem with using that as your unique ID is when you copy and paste data from point A to point B, sometimes those object IDs can change depending on what's been removed from the data over time or what's been added. So what we're going to be asking is that you have a unique ID other than the primary key that is static for each feature within the data set. And the purpose of that is pretty important in terms of relational databases. We're going to make sure that that road name alias table, for example, can join back up to that road center line table. And if we're using object IDs and something changes in the future, then that linkage could be broken. So having a unique ID other than the object ID is pretty important to be able to link things back and forth throughout the duration of the data set. We want to make sure that it's static and it's not changing. So we'll talk a little bit about that in this document that will be sent out to you all here in the near future. One thing to note on, some of you all might already have a unique ID other than the object ID in place. That's perfect. We're not asking you to change it. We just want to make sure that it's static and it's something that won't be changing throughout the duration of the history of the feature in the data set. And if you don't have a unique ID other than the object ID, the document that we'll be sending out will kind of give you some guidelines on how you could probably do that and how you can manage that. And I hope to have that document out to you guys, at least the board, by the end of the week. So that's pretty much getting finished up right now. But those are some of the data collections that we'd be asking for, and that's going to be coming up here pretty quick. All right, next slide. Another thing we're going to be doing here down the road is some training. So we're going to be providing WebDMS, which is a data management services. And so along with that, there's going to be some GIS change requests and a GeoLinks server training. And this will be coming towards, probably towards November. We're going to set up a couple one-hour sessions to kind of go over these tools and how they can be used and how they'll be helpful for you maintaining your data moving forward. As Sean mentioned on that EZNet slide with the cloud in the background, one of the most important things is keeping your GIS data up to date. Since the routing and everything is going to be dictated by your GIS data, you want to make sure that a new subdivision is getting inputted into that GIS data sooner rather than later. And so we'll kind of go over a lot of this on how to maintain and update your data here in November, I believe it is. So we'll be going over that later. Next slide. And then one other layer we're going to be working on and developing is the cell sector layer. And some of you might already have cell sector data, so that'll be another thing that we would be requesting from you. We also have the cell tower locations and information from Intrado. So we'll be putting all of that together to create the cell sector layer and the tower layer, which will be one of the products we deliver at the end of this kind of initial year project. And then I think that's it for me. I think I'm going to turn it back over to you, Christy, for some dates and stuff.
Thanks, John. I know everybody is probably asking, okay, what is my responsibility? What comes next for us as far as county perspective goes? And here are some of the key things that we're going to be working on with the counties. We are finalizing the contact list for our county GIS contacts, and that should be completed within the next day or so. And what we're going to be doing is sending out instructions to those contacts so they know how to upload the data to our ShareFile site in order for us to begin the assessments. We'd like to receive the GIS data from the counties by January 20th. That's our goal, to have most of that in so we can begin those assessments. We will turn those assessments around in a report format and provide those back to the county. And we will also be available to meet with the county or set up a call with the county to go over the results of those reports. There's a period of remediation to work on the different issues that come up in the reports, and we would like the counties to work on that between early May and end of July. And then what we're going to do is, John had mentioned earlier, is we're going to do a second round of assessment and provide a statewide final report. And we're going to be asking for the data again a second time in September. We're going to do the assessment and provide that final report back to the state by early December. And also in the meantime, we're going to be providing some training in early November, as John had also mentioned. And then the last item below lists, this will be ongoing. Once the system is implemented and running, the statewide data set's available to everybody. The county's role would be to, if there are changes to the data, submit those, submit that information to GEOCOM. That could be updated, QA/QC process run. We provide feedback on that, and that would be something that would be ongoing for the next-gen system in the state. That's all we had. Does anybody have any more questions at this time? We have a lot of work to do over the next year.
That's for sure.
Yeah.
Yes, definitely.
We're very excited to be working with all the counties, and we do appreciate the opportunity. It's going to be a great project. I don't see any new questions coming over. Oh, wait. Yeah, no new questions.
All right. Any other thoughts, Ted, at all, or?
Nope. We're thank everybody, and we're looking forward to getting started on this. And we'll remain in touch with communication from Shawnee and GEOCOM as needed. So thank you everybody for joining today.
Yes, great. Well, thank you, everyone.
Thanks, folks.
Thank you.
Bye-bye.
Have a good day.